All right, let's see how we can enhance our methods using decorators. So let's define a person class with the same method that takes a message of type string. And here we log person says the message. Good. Now we're going to implement a decorator and apply it on this method. So just like before, we create a function. Now to apply this on a method, here we need 3 parameters. So instead of a constructor function, we need 3 different types of parameters. The first parameter is the object that owns the target method. So target of type any. Now, I know that I told you that we shouldn't use the any type as much as possible, but in this case, any is the type that the TypeScript compiler expects from us, okay? The second parameter is the name of the target method. So method name of type string. And the third parameter is the descriptor object for the target method. So descriptor of type property descriptor. Now, if you're not familiar with property descriptors, I covered them in detail in the second part of my ultimate JavaScript series. But very briefly, every property in an object has a descriptor object that describes that property, okay? And by the way, you don't have to memorize any of these parameters. If you simply Google TypeScript decorators on this page on typescriptlang.org, you can see various examples. So on the right, we have class decorators, method decorators, and so on. So let's look at method decorators. Here we have an example. Look, we have a function with 3 parameters: target of type any, property key of type string, and descriptor of type property descriptor. So once again, the name of these parameters doesn't matter. What matters is their number and type, okay? So back to this function. Now here we can do some really cool things. For example, we can completely replace this method with an entirely new method. So look, this descriptor object has a property called value that references the target method. So we can set this to a new function to replace the original function or method. So a function with no parameters, and here we simply log new implementation. So now this function is going to replace the same function, or more accurately, the same method in the person class. Now, this is the nuclear option most of the time. We don't want to do this. We want to enhance an existing method. So we want to do something before or after that method. So let's change the message to before. We're going to do something first. Also, we're going to do something after. And in the middle, we're going to call the original method. But before we can do that, first we need to get a reference to the original method. So let's declare a variable called original and set it to descriptor.value. Now, in this case, it's better to use the const keyword because we don't want to accidentally reset this variable to something else, okay? So we have the original function. Now, how can we call it? Very easy. We type original dot. Now look, we don't get IntelliSense here because the type of value property is any. So here we need to use type assertion and tell the TypeScript compiler that this is a function. So right here, we type as function, okay? Now if we type original dot, we can see all the properties and methods of functions in JavaScript. So here we have a method for calling a function. So we call this, and here we need to pass 2 arguments. The first one is the this keyword, so this, and the second one is the argument or arguments we want to pass to the target function. So look, our say method has 1 parameter of type string. So over here, we can hard code a value as an argument. We can say blue sky. So now, if we create a person object and call person.say hello, this value that we pass here is going to get ignored because it's going to be replaced by this hard-coded value, because this is the new implementation of the same method. So in this new implementation, we don't have a parameter like message. We have hard-coded a value that we're going to pass to the original method, okay? Now, what if we want to use the actual argument that we pass over here? Well, while redefining the same method, we can add the message parameter, message of type string, and then we pass it right here, okay? So let's run our program and see what we get. But before we do so, first we have to turn off a special compiler option, because here we have a couple of unused parameters and TypeScript compiler is going to complain about them. So let's go to tsconfig.json. Here in the type checking section, we have a compiler option called no unused parameters. We turned this on earlier in the course, but now we have to temporarily turn it off. Okay? Now here in the terminal, let's compile and run our program. So we see before, then we see person says hello, and after. Great. So using this decorator, we have enhanced our method. However, there is a tiny problem here. With this implementation, we can only apply this decorator on functions or methods with this signature, methods that have one parameter of type string, not very flexible. So what can we do here? Well, to make this more flexible so we can apply this decorator on any type of method, first we need to replace string with any. Then we rename message to something more generic, like args. And using the rest operator, we allow this function to take varying number of parameters. So now we can apply this on a function with 0, 1, 2, or more parameters, okay? And also, while calling the original function, we're going to use the spread operator. So we spread all these arguments and pass them one by one to the original function, okay? So this is how we can enhance a method using a decorator. Now, one last thing before we finish this lesson. Note that over here, we are using a function expression and not an arrow function. If we use an arrow function, we get a compilation error because arrow functions don't define their own this keyword. So we cannot use them as methods in a class. So when redefining methods, we should always use a function expression.